Hey, 7th grade, welcome back. We're pushing into 2.3, comparing costs, and this is going to be looking at comparing the relationships that form when it comes to situations that can be modeled by the linear equation model. Remember, we're going to have that unit rate multiplied times some kind of variable, then either adding 0 or adding some number or subtracting some number that would end up being that starting point or that y-intercept. So we're looking at a lot more deeply today. All right, here it is. So want to make sure we're clear. The biggest thing we're leaning into right now is this opening sentence. All of the linear relationships you have studied so far can be written in the form of y equals mx plus b or y equals b plus mx. And we're talking about what each of those variables are going to represent. The very first one we need to understand is that letter b. That b is going to refer to the y-intercept. Whenever the value of x equals 0, you plug that into the equation, and whatever you end up getting when you put in the value of x equals 0, that ends up being the y-intercept or where that line crosses the y-axis. So if it's a plus number, it will be a positive number. If it's a minus that number, it will be something in the negative area. So it's really important that you understand that. The next thing we need to understand is that letter m. The letter m is that the overall term is called a coefficient. It means the number that multiplies a variable in an equation. That coefficient, or the m in this place, is always going to be our unit rate, our constant of proportionality, the scale factor, and we're going to learn another new name for it in the coming days. So it's really important, whatever that unit rate they give, like the walking rate for Henri and Emile, or the walking rate that came from, the pledge money that Gilberto, Leanna, and Alana got, all of those end up being the unit rate that we put in there for the variable m times that independent variable or times x. The other thing we want to make sure that we're clear on is understanding the solution of an equation. What that means is whenever we plug some value in for x, the other end of it, that y or the dependent variable, ends up being the solution of an equation, like an ordered pair. So if we put 0 in there for Henri's equation, if you recall, if I put 0 in here, we'd have 0 for t, or 0 times 1 plus t. You'd see we would get 45 plus 0 is 45. So that's 0, 45 is the solution. It's that place where we'd put a dot on there from our table data. Hopefully you guys remember all those pieces, because we're going to start using that language more in this particular lesson. All right, here we go. Mrs. Chang's class decides to give t-shirts to each person who participates in the walkathon. They receive bids for the cost of the t-shirts from 2 different companies. Mighty T charges $49 plus $1 per t-shirt. No Shrink Tea charges $4.50 per t-shirt. Mrs. Chang writes the following equations to represent the relationships relating cost to the number of t-shirts. So here it is. The cost of Mighty is $49 plus N, number of t-shirts, and C, or the cost for No Shrink, is just going to be $4.50 per shirt. So it is, the number of t-shirts is N, cost for Mighty is the cost in dollars for Mighty T, C for the cost for No Shrink is the cost in dollars for No Shrink Tea. All right, so here we go. Question A1. For each equation, explain what information the y-intercept and the coefficient of n represent. What's the independent variable and what's a dependent variable? Okay, so what I've done here for A1, we're going to look to find the y-intercept. That's the first thing. So if you recall, the y-intercept is when we put our 0 in for the number of t-shirts. So right away, you can see if I put 0 in here for n, I would end up having 49 plus 0 to equal that cost. So the y-intercept would be $49 in this case. Then from there, they ask, well, what is the coefficient of the n represent? So at this point, the coefficient with n, there's not a number with this. Actually, there is, but it's understood. Remember, if I hold this pen up, do I have to tell you that I have 1 pen here? No, you understand that there is already 1 pen. So I don't need to tell you that. So in this case, if there is just plain old n, then we would need to know that there is just 1 n. So the y-intercept in this case is going to be 49. The coefficient specifically in this particular equation is actually going to be 1, which means $1 per shirt. Okay, that's what that is. So the coefficient is $1 per shirt. And then this 49 for the y-intercept, that means that the setup fee is $49. So it's $49 for setup for this particular company. So that's part of A1, but we're not quite finished. So then we're gonna do for this one over here, for no shrink. So in this case, you see that if I have to work with my y-intercept, and I do another table there for number of shirts and cost, if I put 0 in here for number of shirts, I have, for 4.5 times n, which would be 0, I have 0 cost. So in this case, there's gonna be $0 for setup. And that's what the y-intercept is here. But my coefficient in this case actually is the number that's multiplied times the n. It would equal $4.50 per shirt. That's what that means in this case. So the y-intercept for this one is 0, which means $0 for setup, and the 4.5 refers to $4.50 per shirt. Now in both cases, they want to know what the independent variable is and the dependent variable. So the independent variable, remember guys, the independent variable is what comes first in this situation. And so if you remember our little silly jokes about like having swim lessons on Thursdays and being in the pool and not realizing, oh, I'm in the pool, it must be Thursday. No, we would know that the days would come first telling this. So what comes first in these situations? The independent variable. Do we all of a sudden say, well, it's gonna cost this much, so I figure out how many t-shirts I get? No, you'd walk in saying, I want this many t-shirts. So the independent variable is n, or the number of t-shirts. Okay, and in the other case, well, the dependent variable is what comes afterwards, or what comes as a result of that. So the dependent variable in this case is the cost, or the cost of t-shirts. Sorry about that. I just realized I was writing and you couldn't see the last little bit there. Dependent variable cost for t-shirts there. There that is. Okay, let's move on to 2. So now it says, for each company, what is the cost for 12 t-shirts or for 20 t-shirts? That's for both companies. So in this case, what we actually need to do is take that number of t-shirts and work it into our equation. So for this one right here, you'll see here's our for Mighty T. So I'm gonna bring that down here. So the cost for Mighty T is gonna be 49 plus, and we're using for 12 t-shirts, right? So I'd put 12 t-shirts. So you have the number n equals 12 in this case. So the overall cost for Mighty Tees would be 49 plus 12, which I know to be $61. Okay, so $61 for that particular option there. What about for $12, or 12 shirts, sorry, for our other company over here? So if I do this, I will do the same thing. My cost for the no shrink is equal to 4.5 times 12. And I don't know that one off the top of my head, so I need to do that work over here. 4.5 times 12 is going to be 10. This is going to be 8 plus 1 is 9. Bring my 0. I got 5 and a 4. So this one, the cost of no shrink is equal to $54 in this case. So you can see for 12 shirts, it's a little bit better deal to go to no shrink. But now we need for part 2, we're gonna do the cost for 20 t-shirts. So same exact process. Cost for Mighty T is gonna be 49 plus 20. In this case, you can see pretty straightforward that the cost for Mighty is going to be $69 for 20 shirts. Then over here for the other one, for when n is equal to 20, the cost of no shrink is going to be 4.5 times 20. And again, I need to do that work. So 4.5 times 20, I can bring my 0 down. 2 times 5 is going to be 10. This is going to be $8, $90. So in this case, look at the difference. cost of no shrink is equal to $90 for 20 shirts. That changes quite a bit, doesn't it? All right, A3. Lanny calculates that the school has about $120 to spend on t-shirts. From which company will $120 buy the most t-shirts? Explain your answer. Well, I started this already and I had to go back and edit it because I made a mistake in my calculations, but you'll see I have both of these equations written down. For Mighty T, the cost is equal to $49 plus the number of shirts. And for No Shrink T, the cost is equal to 4.5 times the number of shirts. And we're gonna plug in $120 here. So 120 is equal to 49 plus the number of shirts. So some number plus 49 equals 120. So I'll do that by subtracting 49 from both sides. That's gonna be gone. So if I cross this out, this is gonna be a 1. So I'm gonna have 10 minus 9 is 1. I can't do 1, take away from that. So I have this here, 11 minus 4 is gonna be 7. So it turns out that at Mighty T, they can buy 71 shirts. That's pretty good. It's a good amount of shirts. We'll see what happens over here in this case. So now I'm gonna put in 120 for the cost and do 4.5 times n. Now this is a different one because remember over here we had to figure out the addition part, so we did the inverse operation and subtracted from both sides. They're telling us here to actually do multiplication. The opposite of multiplication is division. So I need to divide 4.5 on both sides. This is going to become a big 1n and I need to do the division. Now remember that's going to be one swoop over, so I'm going to go ahead and set that up. So it's going to be that plus one more 0 divided by 45. So I got to think about this. I know 2 times 2 or 1 or 45 times 2 is 90. 45 times 3 is 135. That's going to be too much. So I'm going to go in 2 times. Okay. So I got to bring that down. Bring down my extra 0. 45 into 300. Man, trying to think about that. 45. Let's see. So 2 was 90. So that would tell me that 3 would be 180, or sorry, 4 would be 180, and 6 would be 270. So let's try 6. So 6 times 5 is 30. Carry my 3 there. 6 times 4 is 24, plus that's going to be 27. And again, I need to do some subtraction. Oh, look at that. I'm going to keep getting another 300 coming down. So it's going to be this 0.66666 kind of thing all the way. So I can't really get part of a shirt, right? I wouldn't want to get that 0.6 of a shirt or 2/3 of a shirt. So it turns out I'm going to actually get 26. This is going to be an about instead. So wow, look at the difference. What company would you want to go with? 71 shirts or about 26 shirts? Huge difference there. So you can see that that work helps us to explain our answer. All right, A4. We have 2 parts here. Part A. For what number of t-shirts is the cost of the 2 companies equal? What is that cost? Explain how you found your answers. Okay, so now we need to take both of these equations and figure out when they would be equal. Now for me specifically, I like to work with equations, but we saw this work come together quite a bit when we were talking about Henri and Emile. So if you remember, when we made the graph for Henri and Emile and we figured out where those lines crossed, that was where they would be equal or they'd be tied in their walking race. You remember that? We had the table going down, we realized it was 30 seconds and we saw that they were gonna be tied at that 75 meters. That was another way to show they were equal. What we're gonna do today is a little bit different. We're gonna actually create both of those equations and set them equal to each other so that we can know when this company, or when these 2 companies will have the exact same cost for t-shirts.